Now we want to talk about solving logarithmic equations where we're using the one-to-one property of logarithms. This is going to be very similar to the lecture when we were solving exponential equations. All right, so it boils down to the fact that if the bases match, so if the base of the logarithms match, then we can just take what's inside and set it equal to each other. All right, so again, if we're in the form log base b of m equals log base b of n, then we can just solve m equals n. All right, so as always, we're going to need to check our answers, or what we think is going to be our answers, back into the original equation. All right, because we cannot get negatives in the logarithms, we can only have answers that are greater than 0, okay, for m and n. All right, so you'll see me kind of plug our proposed solutions back into the original problem just to make sure everything passes the sniff test, as I like to say, but making sure that what's inside the logarithm is indeed positive. All right, so here's an example. We'll start out with the natural log of x minus 3 equals the natural log of 7x minus 23 minus the natural log of x plus 1. Okay, where the heck do we start? Well, we're going to start by simplifying that right side. I see two natural logs separated by subtraction. Is there any way I can combine them into one natural log? You betcha. We're going to use the quotient property, or the division property, to write the right side as one logarithm, writing the 7x minus 23 as the numerator of a fraction and the x plus 1 as the denominator. Now I have a natural log of something equals a natural log of something else. So I can just take what's inside those two natural logs and set them equal to each other using what we call the one-to-one property. Okay, so now how do I solve this equation? Well, I'm going to multiply both sides by x plus 1. That's going to allow the x plus 1's on the right to cancel. And so I have two parentheses on the left, and I've got to FOIL them. Okay, so I'm going to FOIL the left-hand side. So I'm now down to x squared minus 2x minus 3 equals 7x minus 23. The question is, do I start trying to solve for x, or do I recognize that this is quadratic and get everything on one side? Somebody just called my office phone. Strange. Well, I didn't answer it. I'd ignored them for you guys. Don't say I never did anything. Okay, back to the problem. X squared minus 2x minus 3 equals 7x minus 23. We do recognize, guys, that that is quadratic. We have an x squared, so we need to get everything on one side. So I move that 7x to the left side by subtraction. I move the minus 23 to the left side by addition. And so I have x squared minus 9x plus 20 equals 0. How do I solve this? I'm either going to use the quadratic formula or I'm going to use factoring. It is up to you what you use here. For the ease of the problem, I'm going to go ahead and use factoring. I get x minus 5 times x minus 4 equals 0. I then take each factor, x minus 5, set it equal to 0, take x minus 4, set it equal to 0, and I end up with two proposed solutions, x equals 5 and x equals 4. Do they both work? Are they both legitimate answers? Well, we need to check. Let's plug 5 into our equation. All right, what do we get? Well, I plug in 5 and I look at natural log of 5 minus 3 equals natural log of 7 times 5 minus 23 minus the natural log of 5 plus 1. I simplify these. Natural log of 2, does that equal the natural log of 12 minus the natural log of 6? Well, let's use the quotient property and bring 12 and 6 into one natural log using a fraction. What's 12 divided by 6? You betcha, natural log of 2. And so we do get the natural log of 2 equals the natural log of 2. All right, so 5 is indeed a solution for this equation. Let's check 4. All right, I plug 4 in for x into my equation, and I get the natural log of 1 equals the natural log of 5 minus the natural log of 5. What's the natural log of 5 minus the natural log of 5? How many of you think it's 0? Well, let's use the quotient property. What's the natural log of 5 divided by 5? Well, that's 1. And so we do get the natural log of 1 equals the natural log of 1. But remember right back here when I asked you, how many of you think the natural log of 5 minus the natural log of 5, is that 0? Of course it's 0. Something minus itself is always 0. So what's the natural log of 1? Exactly, it's 0. And so from here, I could recognize that indeed 4 is a solution, okay? So we get two answers. We get x equals 5 and x equals 4, so our solution set is 4 and 5.